Okay, so on 3.2, we're going to run through, probably the first couple of parts of this, and then the piecewise functions, we'll probably save that till next week. But what we're going to be doing in this section mostly is I'm going to be giving a function, and then we're going to just look at the function and figure out what the domain and range are of the function. And you'll need to use your calculator at this stage to help you figure out what the range is for the most part. The hardest part of these problems a lot of times is the range, and using your graphing calculator will kind of help you through that, okay? So I've just kind of put up here a reminder of the definition of a function. The domain is all of the x values. The range is all of the y values, okay? So what we're going to look at is taking a function and figuring out what its domain and range is. And you have to learn to kind of categorize things in your head, okay? So basically, if you're figuring out what the domain is, you try to figure out what x can be. Now, if you've got 2x minus 4 as your function, all right, think of it this way. Is there any number that you can think of that you cannot multiply by 2? Is there such a number? No, you can take any number and multiply it by 2, right? Doesn't matter what it is, okay? So the whole key on this is you can multiply anything by 2. So if you think of it that way, x can basically be anything in this problem. That's what you're always thinking about a domain, is you're thinking, what can x be? Okay, sometimes it can be anything. So it can be every single number, fractions, decimals, whatever. Okay, so here's how we write the domain. When I say set builder notation, you want to write it like this. You put a brace, and you put an x, and then you put a bar. This is kind of the standard way of writing that. Now I'm going to give you a symbol. You could either say set of x, you could say x is any real number. You can actually just write it that way. I mean, if you want to write it, but there's a shortcut that you should learn. Okay, if you say x and this funny looking e and then an r with a double bar, that's the way you're going to see me write that x can be any real number. And real numbers are just decimals, fractions, pi, every number you can think of. A lot of you have learned about imaginary numbers, maybe in high school or something. This is something that's just a real number, okay? So you're going to see me write this way. I'm just going to say x, and that e means it's an element of the set of real numbers. That's just an abbreviation. You want to know what that means. So if x can be anything, that's how you write that in set builder notation, okay? Interval notation is the whole entire number line. So how do you write the entire number line in an interval? We've done that before. Yeah, you say negative infinity, comma, infinity, all right? Most of the time, you're going to write your domains in one of these two notation systems. Okay, so that's what that is then, all right? So you have to kind of reason that out. Your graphing calculator, when you're learning this, will help you a lot. So get your graphing calculator out, and not everybody has a real good background for this. So we're going to put in 2x minus 4. So what you want to do is go to your y equals button, and type this in. There's a couple of things that students in this level of class don't know. If you want to put x in, this is your key. That is your variable key right there. So what you do is you can watch the keystrokes. I put 2, then I press that variable button. Make sure you use subtraction. See, this is a negative right there. That minus with parentheses, that's a negative number. So we want to subtract and then put in 4. Okay, so you want to get that put in. Now, as you're learning how to graph, typically a graphing calculator has an automatic, if you press the window button, the automatic thing that it should have is negative 10 to 10 on the x-axis, which is why all my graphs are, and then the y is going to go negative 10 to 10 like that. So you want to know what all these things mean, all right? Now, this is something that you're going to see me doing over and over again in this class when I graph. Instead of just pressing the graph button, do this. Go zoom and then number 6, because that automatically puts you back into a standard window. Because what's going to happen is you're going to change your window all the time this semester. I mean, your standard simple graph is just going to go negative 10 to 10 like that. Okay? All right, so we got the graph in, and then again, just zoom 6 is the best way to graph. Okay, instead of pressing the graph button. Okay? Is everybody okay? Okay? I'm just sort of assuming that you're not experts on the graphing calculator yet. That's my assumption. Now, I want to show you one other thing. You see you have this graph button right here. Above it, it says table. So if you go second graph, it'll just give you a whole bunch of points on your graph. That's a nice thing to learn how to do. And you're getting a line on this. We haven't even talked about how to graph a line yet in this semester. So if you go second graph, all you got to do is just pick a couple of points. Like I see the point, for instance, -2, -8. So I'm just going to go -2, -8 and put a dot. I see a point 0, -4. Just pick a few things out. I don't care what you pick. There's 2, 0, and then just connect the dots. Now a line is going to go on forever in both directions, okay? We did, on that prereq review, we did a little bit of review of y-intercept and slope and all that kind of stuff, but I want to focus on graphing calculator for this, okay? So you're going to notice the domain's everything. That means x can be anything. The graph just keeps going on. The range is this way, okay? So doesn't it look like y can be anything also? If your graph goes on forever in this direction, that means y can be anything, okay? When you figure out the range, you're kind of going like this. You're figuring out where does the graph start, where does it end? Well, it starts at -infinity, and then it ends at positive infinity, okay? So what you're going to find on this problem is what values can y be? They can be anything, okay? So they can be anything. So this time, when you write this in set builder notation, there's one little thing you got to do different. You don't say set of x, you say set of y, because a range is talking about y values. Then you put your bar, and then you can put y, and that e, which means it's an element of the real numbers. That's just that ye with the r just means it can be anything. That's something you should learn how to do, because it's an abbreviation. Otherwise, you got to state that y can be any real number, okay? What's the interval notation? Well, it's still -infinity to infinity. When you do interval notation, you're not going to have an x or a y in it like that, okay? So when you're learning this is the domain is this way, the range is this way. And sometimes graphs go on forever. That's what a line does, okay? Does that make sense? Okay? Because remember, this thing doesn't stop. It just keeps going on forever. Your graphing calculator will show that to you. Okay, so we'll kind of start with that, and we're going to go through some kind of different things that happen. The next one, we need to figure out what x can be without looking at the graphing calculator. Okay, so here's the way I look at this like this. Just look at this part right here. Is there any number that you cannot add 2 to? Now, any number you can add 2, right? Any number you can think of you can add 2. So that's okay. Is there any number that you cannot subtract 2 from? No, you can take any number you can think of, and you can pick a number randomly on your calculator and subtract 2, and you'll always get an answer, won't you? That's why I want you to think of that. And then you're multiplying all this. You're just multiplying numbers. If you take your calculator and randomly pick 3 numbers and multiply them, you're always going to get an answer. Okay, so the thing happens on this is the same thing. X can be anything. If you struggle figuring that out in your head, your graphing calculator is certainly going to help you. But the idea is I can add anything to 2, I can subtract 2 from anything, and I can multiply. Okay, there's no problem. The problems we're going to see is like dividing by 0, or maybe having a square root of a negative number. Those are what we're going to look at. Okay, so the domain, we go like this. We say set of x, put your bar, and then just put x, and then the e, and then the double bar r, and then the interval notation is going to be -infinity to infinity like that. Okay, these 2 examples are going to be, the domain's going to be all real numbers. Okay? Okay, Now get your calculator out. We're going to do this again. I'm going to do this for the rest of this section today. So go to y equals, erase what you had and put the function in. So you just put it in exactly the way it is. There's your variable key, left parenthesis, x add 2, close parenthesis, and then x minus 2 like that. Now I think we're going to be working with standard window in the entire class today. So if you just want to press your graph button, you can. I like to get students in the habit of just going zoom 6 for your graphs. Okay. All right. So there's our graph. Now we're going to do kind of just what we did on the last one. We're going to look at our table of values, pick out a few points, and just draw a rough graph. Okay. So I'm going to go second table, and let's just pick out a few points here and there. Your graph on this doesn't have to be perfect, by the way. So I've got like, there's a -2, 0. There's a -1, 3. What else is there? 0, 0. There's 1, -3. There's a 2, 0, and so forth. So you want to make sure that you know how to get those points like that. Okay, then just sketch it. It doesn't have to be perfect. Just kind of sketch the way it goes, but try to get, 2 or 3 accurate points like that. Okay? All right, is everybody okay with the calculator? I'm assuming that you're not a calculator expert. Yeah. Okay, now let's think about this. The range is this way, right? Okay, what is this graph showing? Is this graph going through every single y value, or is it missing a y value? What do you think? It's going on forever this way, right? It's going on forever that way, just like the line. So what do you think the range is? Is everything, right, exactly. It's going to go through every one of these y values. Every single, that graph goes on forever. Okay, so what you're going to get for the y value is the same thing. Y can be anything at all. And so in set builder, the only difference is we don't say the set of x. What do we say? Set of y. So we say set of y, and then y is a real number like that. Okay, interval notation is the same thing. So what's going to happen is if your graph goes on forever in both directions, this way and up and down, then the domain and range are all real numbers. Okay, we're not going to, that's just a special case. There's all kinds of different ways to function. Okay, on my graphs, do both of these things pass the vertical line test? Yeah, so they're functions. Okay, they're functions. Okay, all right. Now let's go to the next page, and then we'll kind of look at the next thing. We're going to look at 3 cases. Okay, you guys really haven't learned how to do any graphing. So, I mean, at this stage, we need to just learn how to use our calculator, right? Okay, so now what we're going to look at on the next page is a square root function. And the key thing that you have to understand on this is if you do a square root, the expression under a square root must either be a positive number or it must be 0. Okay, we'll talk about why that is, okay? Just depends on your background. So here's the square root of a positive number. The square root of 4 gives you an answer, doesn't it? Square root of 4 is 2. Okay, anytime you do a square root of a positive number, you get an answer. It may be a decimal, it may be a whole number. What's the square root of 0? 0, how come? Because 0 times 0 is 0. The reason why the square root of 4 is 2 is because 2 times 2 is 4. Okay? Now, look what happens when we do the square root of -4. So the thing is, when you're doing a square root, you're trying to think of the same number multiplied that would give you -4. Is that possible? We could try something. Okay, we could try -2 times -2. Is -2 times -2 -4? No. In fact, you can never multiply the same 2 numbers and ever get a negative number. It's impossible. Okay? Because if you do a positive times a positive, you get a positive. If you do a negative times a negative, you also get a positive. So you can't multiply the same number by itself and ever get a positive. So the square root of -4, we're going to say, has no real solution. All right, now there's going to be some things that are going to pop up on your calculator, and I just want to show this to you if this ever happens. So like if I was to go through, and if I was going to go, the way you do a square root on a TI is you go second, and then the x squared button. What? Not like that. Okay, you go second, and then your x squared button. So if I put in a -4, say I'm putting in this negative symbol right here, right? You can't put in the subtract 4, you have to put the negative in. And if you put that in, you're going to get an error. Okay, so anytime you put a square root of a negative number in your calculator, it's going to say error, non-real answer, because the square root of a negative number is not real. Okay? All right, now some of you have learned imaginary numbers at some point in your life. We don't care about that right now. Okay, we will care later. Okay, are we okay? You cannot take a square root of a negative number. All right, so here's kind of what you do. All right, and I went ahead and just kind of wrote this on here. If you want to find the domain of a square root function, you take the expression under the radical and you set it greater than or equal to 0. So we've learned how to solve inequalities this semester. Okay, so this is basically what you're going to do. If you have a square root, you'd have to figure out what makes the thing under the radical greater than or equal to 0. Okay, so let's kind of think about, let's just try to think of this in our head. What would you plug in for x in your head that would give you 0 under the radical? -6, right, okay. So we're probably going to have be -6 and then numbers bigger, probably. So here's what you want to do. Go ahead and write this down. Just write down that x plus 6, take it out of the radical, and set it greater than or equal to 0. Because we know whatever's under the radical must be 0 or bigger. And then solve the inequality. So what we would do is subtract 6 from both sides, and you would end up getting x is greater than or equal to -6. Okay? So what we figure out on this is x needs to be -6 or bigger. I'm just kind of writing that in words. So our domain is going to be -6 and bigger. X can be -6 at the smallest, but it can be anything bigger. Okay? So we write this like this. Set builder notation, we say set of x, you put the bar, and then you just put x is greater than or equal to -6. So that's how you would write that in set builder notation. Okay? All right. How do you write x greater than or equal to -6 in interval notation? Start, comma, finish. How does that go? As a bracket. Now, why does it have a bracket? Because it's got the equal to thing. So you say bracket -6, and then bigger goes to infinity. So we have talked about interval notation. So that's how that goes. Okay, yeah.
Would you ever use like set builder notation? What does that use?
When you're looking at higher level math, you see it, a textbook maybe show it different ways. Okay. So it's just more or less, there's different ways to write for the same language. These are the two ways, so I think it's good to go over both ways. Interval notation is what you're going to use most of the time. Okay. All right. So that's how that goes. All right. Now let's put this in the graphing calculator now, because the range is really pretty difficult to figure out unless you look at the calculator. Okay. So you're going to go to y equals, clear off what you have, and then to get the square root, go second x squared, and then just put in the x plus 6. Okay, and this will help you when you're doing this. It'll tell you if you're right on the domain also. Okay, so I'm just going to graph that, and let's take a look at what comes out on the calculator. So notice that this graph starts at -6 and goes on forever. That right there tells you about the domain right there. Okay, so again, let's just go to our table of values and let's go second table, and let me show you a couple things that happen. Okay, we got a bunch of errors there. Any idea why all those errors are coming out? Under the square root, you're going to have a negative number. Okay, all right. So what's going to happen, like if you did -7, -7 plus 6 is -1, and you can't do the square root of -1. So notice on here, at -6 and bigger, we start getting answers. That right there tells you the domain is -6 to infinity. That right there tells you that, okay? So let's just go through and pick a few points. We've got -6, 0, so I'm going to plot that. I've also got like, let's see, maybe, I don't care how accurate it is. It's just, we can go down and get maybe 2 or 3 points. It's up to you. So I'm going to go to maybe 3, 3. I like the point 3, 3. Okay. And just kind of plot that. And then the graph goes like that. And then it goes on forever. Okay. It'll go on forever like that. Okay. All right. So that's what comes out on the calculator. So the domain is this way. So -6 to infinity. Does that make sense now based on the graph? Okay. The range is this way, right? What does it look like the smallest value of y is in this graph?
0.
0, right there. Y is this way. So that is 0 right there. That has a y value of 0 and bigger. This thing will get bigger forever. It just gets, it doesn't just like quit getting bigger. It'll get bigger forever. Okay. So the way this is going to go is like this. The graph is telling you that y can be 0 or bigger. Okay, so set builder, what we say is we say set of y, and then we say y is greater than or equal to 0. Okay, greater than or equal to. It's got your graphing calculator shows you that the smallest y value is 0. Okay, all right. How do you write y greater than 0 equal to 0 in interval notation? Bracket, and then what? 0, comma, infinity. Very good. There you go. Okay. So that's how that goes, all right? So, when you're doing, homework on this, you want to try to do the domain mathematically, but the range really, at this stage, you pretty well have to use your calculator for the most part, all right? But I don't want you to get totally reliant on your calculator for everything. Okay, the next problem I'm going to do exactly the same way, If you've got a square root function, your whole entire thought process is whatever is under the square root symbol must be 0 or bigger. So you set that greater than or equal to 0. We've learned how to solve inequalities. Watch this one carefully. Let's see what we remember on this. Okay, so we're going to subtract 4 from both sides. Okay, that's going to give you -2x greater than or equal to -4. All right, now what do? I divide by -2. When we divide by a negative, what did you learn about the inequality? You flip the sign. You flip the sign. You have to. We've learned that, okay? So this would really give you, over here, you would get x less than or equal to +2. -4 divided by -2 is +2. Because we divided by a negative, we switch the sign. Now, the graphing calculator is going to show this to you in just a minute, okay? So here's basically what this tells us. It says x can be 2 or smaller. Okay, that's what that's going to tell you on that domain. All right. So set builder would just be set of x such that x is less than or equal to 2. How do you write x less than or equal to 2 in interval notation? That means it starts way over there and then ends at 2. So how do you do that? -infinity, comma, 2, bracket. Less than is that way. That way is -infinity, okay? So this is going to be -infinity to 2 with a bracket like that, okay? So again, what I did on both of these problems is I took what was under the radical and solved the inequality greater than or equal to 0. And do not forget about when you switch that sign, okay? All right, now let's go to our calculator. Okay, so you can clear off what we had. And then again, we'll go second x squared to put in the square root. Then we'll do 4 subtract 2x. And if anything's not working on your calculator, stop me and let me know, okay? Because I want to kind of use today also to get you pretty comfortable on calculators. All right, now let's graph it. Okay, if you look at the graph that's coming on the calculator, does that match the domain we got? Is your graph showing numbers to and to the left? Yes, okay, so that domain is verified, isn't it? Okay, well, you could use your table of values. I see that point -2, 0. So I'm going to put a dot there. There's a 0.02. You could look at your table of values, but you can just basically kind of get that sketched in like that. Okay? All right. So with this problem, now when you look at the range, what is the smallest value of y on my graph? 0. Okay, then what happens? The y values get bigger. Okay, so what's my range going to be?
0 and bigger.
0 and bigger in words, exactly. Okay, so I'm going to write down just 0 and bigger. Okay, and then what I'll have here is set builder. We say, again, with this, make sure that you say set of y. And then we're going to say y is greater than or equal to 0. It's the same as the last problem. And then in interval notation, that means start at 0, include 0 with the bracket, and go to infinity. Okay? So that's how that goes. So the key thing is, a lot of what you're going to be doing in your web work on this, looking at graphs. Here's the domain, here's the range. Okay? Domain is this way, range is this way. Okay? That's the idea. All right, any questions? Okay, so what you have to learn is if you're dealing with a square root, you figure out what makes what's under the square root greater than or equal to 0, so you solve an inequality. Okay? All right, so the next thing that we're going to look at, and we're going to look at 3 cases, is functions where you have a variable in the denominator. Okay? You have to have a variable in the denominator. So what happens is, we know that you cannot divide by 0. You can't have a 0 denominator. So on every single one of these problems, what's going to happen is our task is to figure out what makes the denominator equal to 0. So I'm just going to kind of focus on that denominator right there. Okay? All right. So you can often do this in your head, but you don't worry about the numerator. The numerator isn't going to have any bearing on this. So just write down 3x plus 2 equals 0. We're only interested in what makes that denominator 0. Now we're going to solve that equation. So we'd subtract 2 from both sides, and then you would end up having, you'd have 3x equals negative 2, then divide by 3. So what you would end up getting is x equals negative 2/3. So what's going to happen on this problem is x can be basically anything except negative 2/3. Okay? And because that's the only thing that makes a 0 denominator. That's it. If you have a fraction, that's all you care about is a 0 denominator. Okay? So that is going to mean then we write our answer on our domain. Now we do this like this. We say set of x, and then that bar means such that, and then we just say x is not equal to negative 2/3. And what that says is it says that x is everything, but it can't be equal to that one thing. Okay? So that's how that goes. Now, in interval notation, think about this. You're going to write on the number line, it's going to be forever that way and forever that way, but you can't be negative 2/3. So the way you have to write this is you have to say negative infinity, comma, negative 2/3, parenthesis, and that parenthesis means that you can't be negative 2/3. Then you put the union, and then you go negative 2/3 to infinity. Okay, what you need to understand on that is, I'm saying it can be anything, so it's forever that way, but it can't be negative 2/3. That's why you do parentheses and not brackets. If you put a bracket on negative 2/3, you're telling me you can have negative 2/3. Okay, does that make sense? Okay, so you got to be careful. The parentheses and bracket are real important. Okay, all right, now we'll graph this on the graphing calculator, and these kind of functions would be really, really hard to figure out without, looking at the graph. Okay, now put this in and watch carefully how I do this, okay? You have to do the numerator in parentheses. You have to, okay? If you don't, it isn't going to graph the right thing. So you go like that. Then you do divide by, a fraction's a division problem. So you put x minus 2 divided by, then put in 3x plus 2 like that and close the parentheses. All right, so get that in exactly that way. Anytime you put a fraction in your calculator to graph, general rule of thumb, numerator in parentheses, denominator in parentheses. If you always do that, you'll never go wrong. Okay? All right, let's graph it and see what it looks like. This is going to look kind of weird. All right, so what's going to happen on this one is, and there's going to be a few things on this. That's one of the reasons why teaching this now, some of this, with a lot of depth is not possible, because you have to know more about functions and stuff like that. All right, so basically here's what's going to happen on this. You have this break in the graph at negative 2/3. All right, I'm going to zoom on this graph a little bit right here. So what's going to happen is negative 2/3 is between 0 and -1. What I want you to do is just kind of put a dashed line and label that as x equals negative 2/3. That dashed line does not come out on the calculator. Okay, like that. All right, so that's just kind of it. And then what's going to happen, a lot of this stuff we're going to learn later in the semester, is the graph is going to kind of do something like this. And then there's a break at another number. I probably could have given a better example than this without a fraction. But just go through and kind of draw your graph. It's going like this, and it's kind of going all the way up like that. We'll learn about why that is a little bit later. And then it's just kind of going like this. And then it goes barely above the x-axis and kind of does something like this. I'm hoping WebEx doesn't have, WebWork doesn't have a problem like this, because it would be hard to figure this out at this stage without, teaching you something that we're going to learn later anyway. But let me just ask one simple question. Does it look like that it goes through every single y, or does it look like it's missing a y? What do you think? Looks to me like it's just kind of leveling off there. It looks like whatever this value right here is, it's missing that value. Okay. Now, I'll go ahead and say how I know it, but yeah, go ahead.
Well, in this calculator, if it's continuous, it doesn't look like yours. I don't know.
Okay, you got an 83. These are weird on this 83. Is it's going to look like it goes like a heart monitor, and it's not doing that. There's really nothing there. I mean, just the 83s, we're going to learn later in the semester what's called an asymptote. And that vertical line right there that I drew on there, the dashed line, is what's called an asymptote. Okay, we'll learn more about this a little bit later in the semester. All right, well, I'm going to have to tell you what it is on this. Basically on this, x or y can be anything. It can be anything except 1/3. Right? And I should have given a better problem than this. I mean, I'm going to tell you, you probably won't have to worry about this on your homework, but the way I know is right here. Okay, the number in front of x, you have a 1/3. What's that? It'll be everything except 1/3. So what it's going to be, as far as your set builder, it's going to be set of y, and it's going to be y cannot be 1/3. Well, I'm at this stage, I'm having to show you something that we're going to learn later. I probably could have came up with a better example. Anytime that you have a fraction like this, okay, and if the highest power of x is the same, then this thing right here gives you what's called a horizontal asymptote. Okay, that's all I can say right now. When I looked at the WebWork homework, it was pretty clear they were whole numbers that you could figure out on your calculator. But that's why it's 1/3. Okay, we'll get to that kind of later. I'm not going to worry too much about that yet. So interval notation, we're going to have negative infinity to 1/3, and then union 1/3 to infinity like that. Okay, so I wouldn't worry too much about that. I think the problems I'm going to have you all do in a minute here, I made real sure that the number that y can't be was a whole number. Okay, like I said, this textbook does things in a weird order to me too, in some ways. Okay, all right, let's do one more like this and kind of see how this one goes then. Okay, so with this one, again, we got to factor that denominator. So what we worry about is okay, what makes the denominator equal to 0? And I'm going to keep observing all I can in class. Based on what I've graded on the test so far, a lot of you need to work a lot on factoring. When I teach calculus, I still see it. I still see students who struggle with factoring. You have to overcome that. You must. Okay? There's no escape. All right? You've got to work on it. Right? And if you need help with factoring, come see me. You can sit down probably in 30 minutes and I could probably resolve all of your issues if you take the time to do that. You can come see me on WebEx too. So the first term is x and x. Okay, the last term is 18. All right, and I'll do this again. I'm going to write down everything I can think of, the two numbers that multiply to give 18. Okay, I've got 1 times 18, I got 2 times 9, and I got 3 times 6. I think the reason students struggle with factoring is because they can't do that fast like I can. All right, now, which one of these is the right combination? That's based on the middle term of -3. What's right? 3 and 6. 3 and 6 are 3 apart. So forget the 1 and 18 and forget the 2 and 9. Okay, it's a combination of numbers. So put the 3 and 6 in there. And then what I was teaching you in your first week class, I said, do this visual until you're so good at it, you don't have to do it anymore. That's a 3x when you multiply that. That's a 6x. We are wanting that to be -3x. All right, that middle term is kind of tells you how to do the signs. So how do you make 3 and 6 add up to -3? +3 minus 6. Okay, all right, it's a combination. So you got this then. That's how that thing factors. Okay, all right. And I saw that on the test. I mean, like there was those problems solved by factoring. It wasn't going too good for a lot of you. So anyway, here's what we do. We have x plus 3, x minus 6 equals 0. Now you set each factor equal to 0, and you can learn to do this in your head, and I know a lot of you can do that already. You have x equals -3, and then you have x minus 6 equals 0. Add 6 to both sides, you get x equals 6. Okay, so those are the two things that make the denominator 0. Is -3 makes the denominator 0, and so does 6. So just in words, what can x be? Well, it can be anything except what makes the denominator 0. So it can be anything but -3 and 6. Okay, that's the idea. All right. Okay, so if your function is a fraction, your total focus is, can I figure out what makes the denominator 0? Sometimes there's nothing that makes the denominator 0. Okay, so set builder goes like this. We say set of x, and then we just say x cannot be equal to -3, and you can just say comma 6. It's not equal to those two numbers. Okay. Now, interval notation is going to kind of go like this. If it's everything except -3 and 6, then it means forever to the left until you get to -3, right? And then it's everything between -3 and 6. So you do, parenthesis -3 comma 6, and then it's everything to the right of 6. Okay, so that's how you write an interval. Note that we're just saying that it can be anything from -infinity to infinity, but we can't have -3 and we can't have 6. Okay, does that make sense? Okay, that's what the purpose of those parentheses are. Okay, all right. All right, so it's basically we did a quadratic equation, which we've learned how to do. Okay, all right, now let's go ahead and put this one in the calculator. And again, I hope this one's better than the last problem. I think I needed to be more careful about finding things that had whole numbers. I don't know how this one's going to turn out either. So I'm going to put in x plus 3 over x to the second minus 3x minus 18. I'm just putting the original in like that. Then I'm going to graph that. Let's kind of see what we got here. Yeah, this one will be better. Okay, and again, this stuff I think when we learn a little bit later down the road about asymptotes, it'll help you. Okay, so here's basically what's coming out on the calculator. You see basically these two things. Now go ahead and do this. Do your second table, because I want you to see this. go second table, and you're going to find two errors are going to pop up. There they are, right there. We have an error at -3. Well, that's what we figured out. X can't be -3. We had an error at 6. Okay, so the domain, you're going to see an answer for everything on that table except for those two places right there. Now, what's going to happen on the y values, if you kind of look at this right here, if you kind of look at how these y values are going, you see them just kind of getting bigger and bigger and bigger forever. The y values are going to get bigger, but what's going to happen is they're going to get close to 0. Okay, and this is just something you want to kind of look at on your calculator. Is I'm at x equals 43, I'm 0.027. If I keep going down and x gets bigger, y is going to get closer to 0, but it's never going to reach 0. If I go to the left on this, like if I use my up arrow on this, the same thing's going to happen. You're going to see these negative numbers. I'm at -35 right now. I'm at -0.024. So what's going to happen is the only thing that you're never going to hit is 0. If you just kind of scan through those y values, that's what you're going to see. Y will never hit 0. It'll just get close to 0. All right. So as far as your graph goes, all I want you to do is just kind of a rough graph. What you have is you have this break at 6. X could not be equal to 6. So we have that. And then the rest of it, I want you to just sketch it. You know, the range is just kind of using your calculator to get a rough idea. It gets close to the x-axis, but it never touches it. And then on the other side, it kind of goes like this. Okay, so that's what's coming out on the calculator. And so what's going to happen on your range on this is you're going to find your range. It can be y can be anything except 0. Like that. Now I'm hoping kind of on web work that you're not going to run into too many problems where it's hard to figure out what y can't be. Okay, I mean, because if it is, then there's things that you just don't know how to do yet. Okay, so set builder, we would say set of y, and then we would say y cannot be equal to 0. And then as far as the interval notation, we would say -infinity to 0, and then union 0 to infinity, like that. Okay, so that's how it goes. I think the range on these problems can be a little tricky, but look at your calculator. Look at that table of values and see if you can locate anything that y can't be. Okay, that's kind of the idea, and that can be kind of challenging, I think. Okay, now let's go ahead. We got about 6 minutes here. Go ahead and let's see how many of these problems below you can do on the next page. I wanted to kind of give you a chance to see if you can sort through these. There's 3 problems, and there's one of each. There's 3 cases. There's the square root. What did I say you did to find the domain on a square root? It's under the radical. What do you do to the thing that's under the radical? You got to set it greater than or equal to 0, right? Okay. What if it's a fraction like number 2? Oh, number 2 I have to change too. I forgot to tell you guys that. On this number 2, but so that we won't have that range problem, change that problem number 2 on the next page to 3x over x squared minus 9. Okay? And then let's just see how many of these we can do. All right? Now, so really what you want to do on this first problem, I want you to finish it, but what's under the radical is 8 minus 4x greater than or equal to 0. It's your job to solve that inequality to figure out the domain. You figure the range out on your calculator. On number 2, it's your job to figure out what makes that denominator x squared minus 9 equals 0. Okay? So let's see what we can do. Let's see if you can put this together okay. Doesn't matter. The negative in front of the radical makes no difference whatsoever. It will on your range, though. Okay, I mean, you're not going to know enough about that until you put that in your calculator. But it will make a difference on that. The only thing you care about on a square root for domain is what's under the radical. That's all that matters. Must be 0 or bigger. Okay, that's the idea. Well, on that first one, when you solve that inequality, you're going to divide by a negative number. What do you do on an inequality if you divide by a negative? Okay, got to be careful, okay? And if you make mistakes when you put this in your graphing calculator, it should help you, catch mistakes you may make on the domain. Here and just kind of let you look at it and get it copied down. You can also take your phone and you can take a picture of this if you want to and get it down later. But the key thing that I wanted to kind of mention on these problems is the algebra. Without the graphing calculator, when you set 8 minus 4x greater than 0, you would have got x less than or equal to 2. You would have got that. So your domain is going to be x less than or equal to 2. Well, yeah. Is that better? Yeah, okay. Yeah, I think you probably get a picture now if you need to. Thank you, Daniel. Okay. Yeah, so, and then your graph is going to tell you what the range is. See how the graph's all below the x-axis? Okay, so your range is going to be 2 or smaller. So you're going to have, for your range, you're going to have, or I'm sorry, not 2 or smaller. That should be 0 or smaller, like that. Okay, so that's 0 or smaller. Okay, and then the next one was, well, you solved the equation x squared minus 9 equals 0. And I just added 9 to both sides, got x squared equals 9, and then I did a square root of both sides. So I got x is equal to plus minus 3, which is something we learned how to do. So basically your domain on number 2 is everything except negative 3 and 3. And then your graph is going to show that y can be anything because of this thing right here. It goes through everything. All right, there's not a y. I mean, you have 0 right there. It goes through everything. Okay. On which one? The first one? Yeah, thank you. Yeah, that should be y there. You always use y for range. Okay. All right. Well, take a picture of it and you can hang out for a few minutes and get that put down. And if you have questions, just hang out and let me know. The range is just something you're going to have to kind of work with your calculator primarily.